So students, today in this video we'll discuss one question that is given in your previous year sample paper, and also many times this type of questions has come. Now the important thing is this year from wave optics chapter, your Young's double slit experiment derivation is reduced, means only the formula is there, so derivation will not come. So that's why wave optics chapter, generally one derivation comes from this chapter, either 3 marks or 5 marks. So the high chances that from the superposition principle one question may come, or the intensity distribution the question may come. So one question is that two monochromatic waves emanating from two coherent sources. So the coherent sources means same phase difference is constant. So we have to show that the resultant intensity at a point due to the superposition is given by I equal to 4 I naught cos square phi by 2, and also obtain the condition for constructive and destructive interference. So you know that the constructive interference and destructive interference, like you will get the bright fringe for constructive one, and destructive you will get the dark fringes. So here two waves are given that are of course coherent in nature, means same phase difference, constant phase difference. So the waves are given. Let's say y1 is a wave which is having amplitude A and cos omega t, and y2 is a wave which is having amplitude A and cos omega t plus phi. So phi is the phase difference. Both waves are of same amplitude. You can also practice for different amplitude, like A1, A2, taking different amplitude. Also you can practice this type of question. We'll try to also do that in the next video. So for these two waves, if they will superpose with each other, then their intensity distribution, we have to show that the resultant intensity at a point due to their superposition of these two waves, the resultant intensity I will be equal to 4 I naught cos square phi by 2. So we have to show this, right? So what you will do, just you will superposition means one wave will be added with another, overlap with each other. So when that will happen, we can write the resultant wave y equal to y1 plus y2. We'll add these two waves. Now you should know the trigonometric function like this identity, that cos A plus cos B formula. So that one will use, and else the thing is very simple. So y1 plus y2, when you will add, you can see that we can write A common because both are having A. So cos omega t plus cos omega t plus phi. So this is what you are getting your y, your resultant wave. This is the resultant wave, right? So here we'll add this. Let's consider this omega t is A. Imagine this is your A, and imagine this is your B part. So the formula, you know that cos A plus cos B formula, I think all of you know. So this trigonometric formula, cos A plus cos B. So cos A plus cos B is 2 into cos A plus B by 2 into cos A minus B by 2. So this is what your cos A plus cos B formula. So we'll use that, and we'll find that A into, you can take A because you can interchange it. A plus B is B plus A, right? You can interchange it. Why I'm taking? Because A minus B will be a positive number. Else also you can do in this way, like if you get a cos of minus phi, also cos that is phi, because cos is a even function. Now let me consider this is your A, this is B, no issue for that, right? This part is omega t is B, and this is A, and the region I told you, right? You can interchange also, you can take A, B, but if I take it A, this A minus B, na omega t minus phi, so I will get a cos minus phi by 2, but cos negative is also positive. So here I can do 2 times cos A plus B by 2, that is omega t, plus omega t, that is 2 omega t, and plus phi by 2 into cos A minus B by 2. So that's what I was talking about. Omega t minus omega t 0, so it's only phi by 2, so it's better. Right, you can take omega, this one A, this one B, no issue. So it will be minus will come, just no issue for that. So this one you are getting, that is 2A and cos phi by 2, and you are getting this is cos omega t, 2 cancel out, this one is plus phi by 2. So this is what you are getting your y. This is your resultant wave. So we know that intensity is proportional to amplitude square. We know that intensity is proportional to amplitude square, and this is our resultant wave. What is y? Y is our resultant wave. This is our resultant wave. After the superposition of these two wave y1 and y2. Right. So once we are getting this, so what is the amplitude of this one? Amplitude is this part, the constant part. This one is the oscillating part, and this one is the amplitude. This part is your amplitude. And we know that the intensity is proportional to amplitude square. And let's say the initial intensity of this one is initial intensity, let's say I0 is small a square. This is the initial amplitude of the wave 1. This is wave 2, and both are coherent in nature, monochromatic and coherent. So interference, they are mixing each other, and we are getting dark, bright, dark, bright, dark, bright fringes. Like this pattern we are getting. So here the resultant amplitude is this one. So we can write the intensity, resultant intensity is proportional to this square, that is this is proportional, right? Or I naught equal to, you can write k a square constant into a square. So here will is proportional to 2a cos phi by 2, or you can say whole square. If you remove this proportionality, you can write constant into this. So you can write this is k a square 2 squares of 4 and cos square phi by 2. Is it clear? I think it's clear. Here we have just this is proportional to 2a cos, this is amplitude square, so 2a cos phi by 2 whole square. Now this is 4, 2a whole square is 4a square whole square phi by 2. Now k square is what? This small a square is initial intensity, k square. So we can write that I equal to 4 I naught cos square phi by 2. Phi by 2 is the, phi is the phase. This is the intensity. This is the intensity, resultant intensity. Now also in the question it is asked that find out the condition for the constructive and destructive interference. So for constructive interference, what will be the condition? Constructive means brightness, you will get the brightness, right? Bright fringe. So bright fringe condition means it should be maximum, right? The intensity should be maximum there. So maximum means this quantity. So I naught is a fixed one like k square, and 4 is a constant. So if cos phi by 2 will be maximum, then this part will be maximum. So when cos becomes maximum, so cos becomes maximum, like cos phi by 2 will become 1, cos maximum is 1, right? So cos phi by 2, it will be maximum cos phi by 2 plus minus 1, because square will be maximum, right? Cos square, so minus 1 whole square also 1. So maximum value will get plus minus 1 and cos is 1, right? Cos 0 is 1, right? And cos pi is -1. So 0, pi, 2 pi, 3 pi, like that. So we'll get basically in general form, if we want to write, cos will be cos pi by 2 will be 1, that is for cos n pi. We can write like this: cos, for cos n pi you will get 1 minus 1, 1 minus 1, like that. And this is the maximas. This is the where we'll get the maximas or bright fringes. So you can write that this is 5 by 2 is equal to n phi, or you can say your phase difference should be 2n pi. This is the condition for constructive interference. This is for constructive interference. For destructive interference, that is the minimas, this is maximas. Okay? So these positions, this phase difference, if the two waves are having this phase difference of 2n pi, then you will get the maximas. So this is maximas. So minima or destructive, this is the condition for the constructive interference if the question is asked like that. So this is destructive interference. The condition will be that cos pi by 2 should be 0, so that you will get a minimum 0 intensity, that is minimum intensity you will be getting. So cos pi by 2 will be 0 where? It's at pi by 2, it's at 3 pi by 2, like that. It's also, yeah, so you will get at the odd numbers. Basically you are getting that the cos, you are getting basically for cos n plus half pi, n plus half pi, or for putting n equal to 0 you are getting pi by 2, n equal to 1 you are getting 3 by 2, 3 pi by 2, like that you are getting. Or you can write that for 5 by 2 is equal to n plus half pi, or 2n plus 1 pi by 2, or you can write this, you can take LCM, this is 2n plus 1 by 2 pi, 2 cancel, or phi equal to 2n plus 1 pi. This is the condition for destructive interference. This is the condition for the destructive interference. The condition for destructive interference, that is 2n plus 1 pi, and this is 2n pi, right? So you will get the maximas, the minimal, maximum, dark bright in these conditions, right? So if the question comes like this, two coherent sources, these are coherent sources, coherent sources. Okay. Two coherent sources, if they are superposed with each other, so the intensity, the resultant intensity distribution will be this, and derive the expression for conditions for constructive and destructive interference. If the question is like that, so you can derive in this way. I think this is clear. If it is not clear, if any step which is not you can't understand properly, you should write in the comment, so that in the next video when I will make, I'll try to clarify your doubt and explain it again if possible. So I think what we have discussed is very important for the board examination, and also for if you are going through the theoretical part and try to you are interested in understanding the theoretical part of this concept, it's also will be helpful to you. See you in the next video. Thank you for watching.